Hey, my name is Rihanna Rochin. This is EMOS in STEM. Today I'm going to be talking about HDGFL2 and its potential as an ALS biomarker. HDGFL2, specifically its cryptic exon, is a protein detected at high levels in ALS patients' brains and spinal fluids. HDGFL2 antibodies can be potentially used as a biomarker for the disease by clumping around the unusual protein in suspected patients, diagnosing them early on, and potentially lengthening their lifespan, meaning HDGFL2 is needed for ALS research. HDGFL2 is only produced in mammalian cells, which unfortunately is very expensive and risky as it has a low production level. This has led to declining research on the subject. A potential solution is using E. coli to create this protein. Some may say that it won't work because of the glycosylation machinery that E. coli lacks. Not every protein needs that glycosylation machinery to function. I attempted to produce a fully functional HDGFL2 protein using E. coli bacteria. I encoded a HDGFL2 plasmid and placed it into E. coli bacteria. I heat shocked them, put them in a bioreactor, centrifuged it down. Got the pellet, purified it at different stepulations, and at 2.6 you can see my protein right here. As you see with this molecular weight ladder, the protein also sat at the accurate level for the HDGFL protein that we were looking for. That's how we were able to identify this band as the protein. So I took this sample and sent it off for bioassay and sequencing testing. The sequence testing came back accurate for the protein, which means it was successfully made, but the bioactivity wasn't fully there, assuming that an enzyme cut the protein during the process, which means that this is fully producible if we add enzyme inhibitors and retry the experiment. HDGFL2 can potentially be recreated through these processes. It would eliminate the costly long practices mammalian cells create, as well as produce a higher yield of protein for the amount of effort placed. The results of my experiment can make HDGFL2 cryptic exon easily available to the public, making ALS research viable and potentially lead to a cure for the disease. Thank you. These are my sources. Emo in STEM, out.